Hi everyone. I'm Giorgio, the host for today, and we will talk about a really hot topic. And we have an international speaker. He is a senior specialist solution engineer for VMware Tanzu. Welcome, Timo Sam.
Hi, everybody. Welcome. I hope you already have some beer, wine, or water to enjoy the session now. And the session for today is going serverless using the Spring Framework ecosystem. So first, I will really talk about what serverless is and why maybe you need it. And after that, I will show you how a typical Spring Boot application behaves on a serverless runtime, in this case, KNative. And afterwards, I will show you how to optimize the experience and especially things like the startup time and the performance. Just a short introduction of me. So as already mentioned, my name is Timo Salm. I work at VMware in the VMware Tensor portfolio. I'm a specialist for Tensor Application Platform. It's a fully integrated modular application-aware platform on top of any Kubernetes. So really with a focus on the developer experience. And so for sure also Spring is part of the VMware and VMware Tensor portfolio, and therefore I'm also doing talks and demo codes, whatever, for Spring. Let's begin. So for today, if you have any questions, just write them in the chat. So then I will try to answer them afterwards, because it's not that easy to switch between the chat and the workshop environment I will use. So for Spring I/O, last week I was there and did a live workshop on the same topic. And to not have to switch between slides and a terminal or something like that, I will use that same workshop for today's session. And as said, I will now start with the introduction of serverless.
Yeah, great. So we are really happy to have you today in Spring User Group Italy, and the stage is yours. Enjoy.
Thank you. So I hope you should now all able to see my screen.
Yeah, please share your screen. Yes,
perfect. So the first thing for sure is to understand what serverless is. And so serverless is not just one thing. It can be grouped into two areas. And the first one is backend as a service. And the goal of that is really to replace server-side self-managed components with off-the-shelf services. One example is, for example, that you could, for sure, in your Spring Boot application, implement your same or your own authentication services. But at the end, it's a lot of effort that could be done by an external company or a vendor, like, for example, Okta or Auth0. And if you're using their services, so they manage everything for you, they manage the servers, they just provide you an interface that you have to integrate. That's an example for backend as a service. Also, for example, if you're familiar with implementation of native iOS applications, a lot of them, what they have is a lot of logic on the client side, so on the iPhone itself. And then to store and share information, they usually use, for example, a cloud service like Firebase or Parse to just save the information. And for the iOS developers and Android developers, it's really easy because they don't have to know all those server-side things. So how to manage it, the application, how to build a server-side application. And that's backend as a service. The other group is function as a service, which is a new way of building and deploying server-side software. And the difference is that instead of having one application or also microservices, instead you have functions that are really specialized for one specific thing. So a common use case is, for example, that if you have a lot of data, streaming data, let's say, and you want to filter out the data, manipulate the data, and for example, if you have a lot of images, with machine learning to recognize some stuff, then that's a typical use case, for example, for functions. And I think the most popular function as a service runtime then is AWS Lambda. So everything what you implement for AWS Lambda goes more or less in the direction of function as a service. Let's have a look at the key characteristics of serverless. And the first thing is that it does not require managing a long-lived host or application instance. So as you maybe know, without that serverless, it's like, okay, you usually have some instances of your application running in VMs or maybe also containers. And they are there for all their lifetime or until there is a new a version of the application available. And with serverless, it's the idea is that you don't have to care about it, and it's like, okay, you don't care about whether that's instance of a service. And with that, for sure, if you have a serverless runtime, you need capabilities to spin up your application instances and hosts, and also to terminate them if they are not required anymore. And that's a big benefit also regarding, for example, reducing costs, etc., of serverless runtimes. Another thing is for sure that implicit high availability that goes in the same direction, because at the end, it's like if you have a lot of instances running in parallel and they are stateless, which is more or less a requirement of serverless, so that you have stateless applications instead of others that store the state, let's say, in a file system or whatever, then it's really hard to have a high availability. So one requirement is more or less that the applications are stateless and not stateful. With that implicit high availability you have, and those for those stateless applications, you can then or the runtime can scale from 0 to hundreds of containers within seconds. Also important is that the performance capabilities are defined in other terms than host and size, as the host size and count. So it's like that for sure every application needs its performance, but at the end it's like really that scale, and then it's more based on the usage itself instead of just, okay, how many CPUs do I reserve for that application. At the end it's like those applications, the serverless applications, they can consume a lot of resources in a short time, and also regarding the performance, and then on the other side, if there's no demand, they will be scaled down, and therefore it's more about that number of instances than having one big VM with a lot of resources. So the question is, with all those capabilities, what is really, or why do I need serverless? And as said, with the backend as a service, at the end it's like it really gives you developer productivity. So also from developer side, you don't have to care about the runtime, but for sure also on the app operator side. So they don't have to build the platform, manage the host, etc. So everything is abstracted away, which is a big benefit for developers and operators, because with that they don't also have to care about, for example, scale, etc. And also with function as a service, as an example, it's like that you as a developer only can focus on high level, really easy to deploy functions instead of those big applications, for example, and that maybe has to deploy it on a specific infrastructure, and you also have to care about the infrastructure. Let's say, for example, a deployment on Kubernetes and using those config maps within your application. So that more or less should be completely abstracted away if you use functions. Another benefit I already mentioned is really that scaling, that it happens automatically. And with that, it's possible to really reduce the costs of your applications, and for sure also to ensure if you have more demand than usual, that this can be provided to the users at the end. You know that if there's, for example, Black Friday, that all the traffic can be served and the users are able to order the goods you offer to them. Another thing is for sure regarding the labor costs. So people that you have in your organization that you have to manage the infrastructure, etc. If you have backend as a service or also then function as a service, because the developers can focus on implementing that business value instead of for example, how to run the application on Kubernetes. You also reduce or don't need that much people, or the people can focus on other stuff. So therefore, that's also a big benefit. And at the end, serverless is really, the benefit of it is that it reduces a lot of risk. So regarding those components, you can just buy from other vendors. Also, regarding for sure the complexity of that solution itself, so you don't have to care about it. But so that sounds really great. I can reduce costs, I have some additional capabilities, and I can focus on that stuff I really want to do. So I would say, in case of the developer, create new business value by new amazing functionality instead of how can I deploy my stuff on Kubernetes and how much instances do I need for a specific day in the year. So that sounds really good, but at the end it also has several drawbacks, serverless, and one of them you maybe already have seen at Twitter, some messages that people spend thousands of euros for their AWS bill, whatever, and at the end it was like they didn't really control their costs. And one problem for sure with the serverless runtime is that auto-scaling. So if it's wrong configured, it could be that if, for example, someone tries to attack your service, or let's say you have maybe also an error in your service, that creates a lot of requests. It could be that so technically it's possible that a serverless runtime like KNative scales your application to thousands of containers that are then running in parallel, and with that you have a lot of you have a risk of unpredictable costs at the end. So that's also something you have to be aware of, and you have to configure. For sure, with all the serverless runtimes, it's possible to do that as of right now, but you have to remember that and do it. Another thing I already mentioned is that serverless applications more or less should be stateless, and also I would say every Kubernetes application should be more or less stateless, because without that you don't have the benefit of high availability or that scaling, and that's a big benefit of Kubernetes and also serverless runtimes. For that you should really have others or save your state of your application in, for example, a database. So a solution that's able to handle that stateful data, and also, as you maybe know, so it's also possible for sure to run databases on Kubernetes, and they are stateful, but at the end it's like they have the mechanisms via a replication to also share their state, that state, and then have that high capability. So for sure you could also implement that in a way, but at the end it's easier to have your application stateless and just use, for example, a database, or also maybe a blob store, whatever, for the state. And at the end, also with those serverless applications, because they are stateless, they have to interact with a lot of other components, as I mentioned, for example, the database, and also there are a lot of, normally in those, especially if it's function as a service, they have to communicate with a lot of other applications, which in the end introduces latency. And that's also something you have to handle and be aware of, maybe also with caches, for example. But it's like if someone calls your application or the front end of your application, the API, and if there are a lot of other distributed system, other application parts or components communicating, it's like that with each call you add additional latency, and it could be that at the end it times out for the client, which you should be aware of. Another problem is regarding that, serverless capabilities and the ability to really scale your application for a lot of demand. Let's say, for example, at Black Fridays, you have to be aware of the fact that even if your newly built serverless application is able to and runtime is able to serve that traffic, there could be that downstream systems, like, for example, the database, is not able to handle all those, let's say, transactions, for example. So you have to be aware of that and also test that with a let's say maximum number of instances you want to have for your application, that you test that your database is able to handle that traffic. Also, another one is that loss of absolute control. So let's say you have auth 0 or Okta. It's like, okay, you have to trust that they do the right thing, and you just are able to call the interface, and that's it. So at the end, you don't have any control usually about the underlying systems, etc. So it could be also something, maybe you could run into problems because of that. Another example is, for sure, if you have a service like this or use a service like this, if that service is down, you're not able to do anything. So you should be aware of that. And last but not least, also the debugging and local testing is more difficult. And for sure, with services like AWS Lambda, there's a vendor login. If you use that native, okay, here's my function in a specific AWS Lambda format. But nowadays it's also possible, as I think it's already available, you can also deploy containers to AWS Lambda. And therefore, it could, I will also talk about it later, but we also provide the capabilities with open source, so-called cloud native build packs for KNative. So it's an open source engagement to make containers really tiny just for functions. And then you can also deploy them on AWS Lambda, I think, already. And therefore, then you wouldn't have that much of a vendor login, like provide or deploying your functions as in an AWS format. And summarize. So the primary drivers for adoption of serverless are developer productivity, which is important, platform elasticity, and then for sure at the end to save costs. And for sure, that's also then, if you have that large number of containers, there also the resource usage of each of the containers is really important. And we will then in the next few sections see how to optimize that. Regarding serverless runtimes, I already mentioned AWS Lambda. That's not the runtime we will use today. So what we will use is KNative. And KNative is a serverless runtime available as open source as of right now. So it was initially built by Google, and then other vendors like, for example, Red Hat and VMware, they started to contribute to it. And nowadays, Red Hat and VMware are more or less the main contributors to KNative. Google for sure also contributes to it, but the founding team at Google, they joined VMware because they were not happy about how that KNative project was handled in the community. But at the end, it's a really great solution. And so previously, or in the past, it was it included 3 parts. The first one is KNative Serving, which provides really that high abstraction on Kubernetes, so that serverless runtime that enables rapid deployment and upgrading and routing and auto-scaling of containers. So it's really containers that you deploy at the end, and the story is like, okay, here's my container, and then you will get back a URL. So the ingress service deployment, everything will be just created for you automatically. And also the auto scaling is configured by default. So you really don't have to care about all those nice capabilities of the serverless runtime. For sure, you can tweak them if you want to and configure more stuff. But at the end, it's really that high abstraction where you say, here's my container image, and then you have a URL. The second one is KNative Eventing. And today we will mostly focus on serving. The eventing is really a system to consume and produce events. So especially for event-driven applications, a great solution. It's using a standard called Cloud Events, which is also popular. So a lot of infrastructure services, or also on AWS, they are already conformant with the standard. And then you can really build event-driven architectures and applications with that solution. And at the end, for sure, it's using asynchronous messaging to communicate, or to make that communication possible between different components. The third one, which is not yet any more available KNative, but as an extra component, is KNative. A solution to build containers out of Docker files. Regarding KNative serving, as said, so that's really the solution we will use today as our serverless runtime, and it's has 4 custom resource definitions for Kubernetes, or at the end, that those are the objects that are relevant. Just that I have them introduced. So the first one is really the configuration. So at the end, how your running system should look like. So the minimal configuration is, okay, what's the name? What is the container image? And then for sure you can tweak things like, okay, the resource consumption of your application, or each instance, for example, setting environment variables, etc. Then we have revisions, which is a snapshot on a configuration. So if you create a configuration, a new revision will be created. And if you change something in a configuration, a new revision will be created. And the benefit of those revisions is that you can, if, for example, you see, okay, the latest version is not working anymore, you can fall back to the previous revision. And it's also possible to split the traffic between revisions, for example, to do blue-green deployment or canary deployment scenarios. Then we have a route which maps network endpoint to one or more revisions, so that you can just call them. And at the end, it's like you can, via different URLs, you can call different revisions, but there's one URL that really then, based on the traffic split, calls a revision for you. And last but not least, and this is the object we will use, is a service which combines a configuration and a route. So at the end, it's like normally you only, if you create and change things, you interact with that service object. And for our examples, we will use the KN CLI, which is the official CLI for KNative, but you could also, because it's completely Kubernetes native, use custom resource definitions. And so there was a lot of theory at the beginning, and now I think it's time to test our first application on a serverless runtime. It's a really basic Hello World application, but it's enough to show the capabilities, and also to introduce other things like, for example, GraalVM. And what we will do, I will just click on that command because it will take some seconds. At the end, what it does, it builds a container image out of that application source code that's available in that folder here. And so how's it doing that? At the end, it's running that build command on my local Docker runtime. And for that, it's using so-called cloud-native build packs that are standard created by Heroku and Pivotal. And the idea is that those build packs, they have a detect step where they see, okay, is that source code I provide, is that build pack able to build the application and also provide a runtime to it. And then it will go through all the different build packs it has, so for different technologies, programming languages, frameworks, whatever, and also integrations. And then all those build packs that are able to provide some functionality for that specific source code will start building, for example, the application as we can see here, and then putting it in a middleware or runtime environment. And that cloud-native build pack support was introduced at Spring Boot 2.3. And yeah, with that Maven, and also for sure it's available with GraalVM, but with that Maven Spring Boot build image command, and here we specify the image tag. This can be also done in the POM XML, but here we do it like that. We automatically, a container with best practices in mind will be built, as you can see here. Yeah, that's really a recommended way to do that, because then you don't have to create your Docker file, and all those best practices from the Spring team are already inside of that container image. Like, for example, also, which was also introduced with Spring Boot 2.3, a layered jars, so that only if you change something in your application code, and in most of the cases you will not change the libraries that are used, and then only that small layer of your application code will be rebuilt, and the rest will be or is cached, the rest of the layers, so all the libraries, etc. And with that, you save a lot of disk space and also traffic if you push it to a container image. So now our container image is built. We can have a look here. You can see it's available. That's the one we built. So you can ignore that 24 years ago. For sure, I built that now. And yeah, what we do now, we push it in a remote registry to be able to consume it on our serverless runtime, which is at the end KNative, that is installed in a Kubernetes cluster. In this case, in the same Kubernetes cluster the workshop here is running on. And as soon as it's pushed, we are able to deploy it on our serverless runtime with a KN CLI. You can see KN service create, name of the service, the image we want to deploy, and I have some scale min set to 1. So this is really the configuration I mentioned. So by default, it's scaled to 0. But I want to show you some performance metrics, and therefore I scale it to minimum to 1 instance. But I don't specify the maximum, because that's specified in the KNative installation I have here. But yeah, you could also, for example, set a scale max to a number, let's say 20 instances, or that something like that. And yeah, I execute a command. You can see it will take some time to deploy it, so it will create a deployment for you, a service, an ingress, and also those other components I mentioned. And then you can see here's the URL to it. So that's it. It's running on a serverless runtime. You don't have to care about any specifics of Kubernetes. And if I run curl to it, you can see, okay, it works, my application. And yeah, so regarding so as I said, what's important also for the cost reductions is for sure the resources that we consume. And for that, we will first have a look at the first performance metric at the end, and that's the startup time. Because as you know, maybe if I have scaled to 0, it takes some time until my application is started. So for usual, let's say Spring applications, it's several seconds normally. And yeah, let's have a look at our Hello World application. It was able to start in 3.5, around 3.5 seconds. So yeah, at the end, it's like if you have scaled to 0, if someone would make the same request I have here, the client would have to wait 3.5 seconds to until the demand will be served. And for sure, if you have, for example, a lot of different services, as said, that are calling each other, it could be that at the end the client times out, which is not great. What we'll have a look at now is really that scaling capabilities. And for that, we'll have a look at the pod. So as you can see, currently it's 1. And if we run the hey command here, which is generating traffic, you should be able to see that a lot of containers will be started. And at the end, it will take, I will just end the command, that not that much will be started. So as you can see, was around 4,000 requests I sent here. And now all my instances are running. And then they, because there's no demand anymore, they will also be terminated automatically. And with a Kubernetes top command of the pods, we can see some metrics. So how much it consumed. And interesting for us is the user container, because the kubeproxy is a Kubernetes component that will be deployed to that container, or as an additional container in a pod, to provide the information whether the application is available, etc. And yeah, we can see that yeah, it's around memory consumption 200 megabyte, and yeah, regarding the CPU, let's just have another look. It's around, yeah, let's say 2 to 3 CPUs are used for that. And yeah, that's a good start, but at the end, something we can maybe optimize. And yeah, especially regarding the memory and the CPU, that's at the end what the costs are, and that's what yeah, I would say every company that uses serverless wants to optimize. And yeah, because at the end it's like faster startup time, low resource consumption, and at the end how you save the costs. And yeah, for that there is a new yeah, application runtime available, or a new way of how to build your software. And yeah, at the end, in traditional Java applications, it's like that the code will be compiled into bytecode, and then you package it, for example, in a jar file or WAR file, and that will be run on a JVM. And that JVM will then, with a bytecode interpreter, run your application on a host platform. And the big benefit of that of the JVM is that it's not bound to a specific architecture operating system. So it's like you build it, let's say, on your Windows laptop, the jar file, and then you can just yeah, deploy it on a server, on a Linux environment, because at the end you have that abstraction of the JVM. And yeah, or for better performance, there's also a so-called just-in-time compiler that is able to translate those parts of your application that are often used into native machine language. And that really tries to somehow mitigate a little bit the problem that those bytecode has to be at runtime compiled or interpreted. But at the end, it's like, yeah, as we saw, so this is what we saw, it's not the best experience for serverless, or it's not enough. And because of that, yeah, so-called chip compilation, it impacts the startup time. So this is mostly why it takes so long to start our application. And it also consumes that much memory and CPU because of that JIT compiler. And yeah, there's another way to do that, and that's called ahead of time compilation, where the Java code will be directly compiled in a standalone executable, a so-called native image. And yeah, that makes the application a lot faster and consumes fewer resources. So as you can see here, it's like with a JIT compiler, you have your jar file at the end that will be deployed on a JVM, and then you have the compiler that for yeah, some paths in the application that you execute several or a lot of times, the JIT compiler with those additional resources that it uses will compile it into native code parts of it, and then yeah, at the end it will be executed. With ahead of time, it's like you have your native image at the end of the build process, and it will be just executed without any additional runtime. But the problem for sure is that it has to be built for a specific architecture and operating system. So if you want to have it running on a let's say ARM, Unix, whatever server, then you also have to build it on a ARM Unix server to be able to execute it. So the portability is not there anymore. And yeah, at the end, as I said, their native images are standalone executables of ahead of time compiled code. And that means that all your source code you have, so from your application source code to dependencies and also runtime libraries that are part of the JDK, they have to be statically analyzed and linked in that native code. So at the end, what that build tool for the native image is doing, it's trying to find every execution path of your application with all the different dependencies and put that into one image. And then, for sure, the benefit, it doesn't have to run on a JVM. You can just execute it on that environment. But as said, the problem is it has to be for the same operating system and machine architecture. Yeah, the benefit is also that it then requires fewer resources to run the application. Also, the native image is smaller at the end. But one problem is, for example, the build time. Because I said it has to analyze any of the different paths and any library, whatever has to be included, it takes a lot of more time. And currently, the only way to build native images is to use GraalVM. But yeah, there are other technologies that maybe will do that also, or make it possible also in the future, like, for example, the OpenJDK project Layton. And yeah, what is GraalVM? So the runtime we will use. At the end, it's like, it's not only providing the capabilities for native images. In addition, it also has a completely JVM runtime mode. That native image, and it has another runtime that's called Java on Truffle. With that, it's possible to also run other languages and frameworks, like, for example, Node.js or Python, on top of that GraalVM distribution. But for now, what we want to really focus on is really that ahead of time native image compilation. For Oracle, so also of that GraalVM, Oracle is the main vendor, I would say, and yeah, their goal is really to get more or less every application on top of that new distribution, JDK distribution, and therefore it provides all those different capabilities that you can really, based on what you want to achieve, use the runtime mode you want to. The trade-offs of JVM versus the native images, you can really see that here. So at the end, it's like the benefit of the native image is the startup times, the memory footprint, and yeah, also regarding that, and then yeah, so that's for the open source GraalVM. For the enterprise GraalVM, it looks a little bit different regarding the throughput here. So they try to optimize that, but in the end, it's like if you have an OpenJDK application that runs on the JVM, a big benefit there is the build time. So developer productivity at the end, the maturity, but also GraalVM gets mature really, really fast. And then for sure the latency throughput through that JIT compiler. So that's a big benefit. Also, if you have applications with a lot of throughput, then it makes sense to use OpenJDK. Biggest problem as that with native images is, I think, this one here, and we will see that in a minute, the build time. And yeah, so another limitation of GraalVM, so not just only the build time and maybe some throughput, is really that at the end, it's what's doing to compile a native image is a static code analysis. And the problem is that it's with that not able to use or detect dynamic features of Java, like, for example, reflection, resources that you load, dynamic proxies, for example, and yeah, also the class path is fixed at build time. So this is really what you have to mitigate, or also GraalVM tries to mitigate with some tool it provides, also Spring Native, which will hopefully also have some time to have a look at. And another one, just that you know that, and there's one example where you would also see that, but I'm not sure whether we will be able to see that today, is that because of the fact that it will analyze the code at build time, so every of your passes, it could be that some of the code, like for example a thread, will run at build time and not at runtime if you don't configure it correctly. So that's another thing you have to think of. So it could be the case. Let's now have a look at our first native image that we want to build. And GraalVM provides a so-called native image utility that you can use for that building of the native image out of a compiled Java application, and also a jar, for example. And that one, as mentioned, it uses or includes an ahead of time compiler that then statically analyzes your source code. And for the sample, we will just use that really basic hello world example. And yeah, what we do is, as you can see here in the commands, we first will to compile it hello world, so it doesn't include a compiler. It just then, based on the compile code, does that static analysis and yeah, creates the native image. And as you can see, it's a really basic example. So at the end, it's system out println, but still this will take some time to build that native image out of it. And this is also the reason why I'm not able to show you that much examples or that many examples today, because especially for larger applications, it takes a lot of time. So I hope that we are able to see that example I showed before on KNative, but then regarding those mitigations, I can provide you the source code and you can have a look at it, how to mitigate or yeah, provide configuration for the native image that you can enable those or use those dynamic features. And as you can see, it's done. And for that really basic building of that hello world application, you can see how much resources were needed just to build that. So a lot of CPU and memory just to build that hello world. But it's finished now. It just took 1 minute to do it. I think with a JVM, it would be around, let's say, 5 seconds. And but you can see, okay, it worked, and we can also just rerun it. You can see how fast it is. So it's if you are in the right directory. Okay. So it's really fast, but at the end, as I said, it takes a lot of build time. And yeah, those limitations I talked about, so reflection, for example, with GraalVM to mitigate those. So here you can see a reflection example where the class for name, for example, will be used. And for that, let's first run that on OpenJDK. And you can see it should just work. So those functions, they reverse the sentence we have, then it capitalizes the sentence we have. So that is working. And if we would run, I will not do that now just because of the time, as a native image, it wouldn't work. So it would say class not found, string reverser and string capitalizer, because the problem is that it's not able with a static code analysis to detect the usage via those dynamic features, in this case, reflection. And to mitigate that, there is with a GraalVM, and this is why I'm here. So before it was running on standard OpenJDK, but as said, GraalVM also has an OpenJDK mode, and in the future, if we would run something here, we would just use the GraalVM OpenJDK, because I didn't want to jump back in that workshop. But at the end, it's like what's using is that agent lib native image agent, which is part of GraalVM or the GraalVM OpenJDK, which will execute that code. So like, for example, as you can see here, the string reverser reverse function, so the same we called here, on OpenJDK to generate the configuration for GraalVM that it's using in that function those dynamic features. So at the end, we're by executing that, we provide a configuration for GraalVM that it knows which path it has to include, or at the end, which class and methods. And we can have a look at that generated by that agent here. Sorry, generated config file. So that's the stuff that was generated. You can see that includes the name of the class and also the method we called with that. So it's, and this is how you more or less for every of the dynamic features with GraalVM, you can provide that configuration if it's just a Java application. So we'll see with Spring Native, there's some more better support or capabilities available. But for GraalVM itself and standard Java, you could use that agent lib to generate a configuration based on the path you execute. And for sure, you could also use, if you have a great, a good set of tests that more or less test every part of your application, you could use your tests to generate all the configuration so that the native image at the end is aware of all the different paths you want to execute, also for the dynamic stuff. And just as you saw an example, so here also, for example, the resources, you can see get resources stream of the config properties. That's something usually also wouldn't work. It would just at runtime is not able to find that resources. And for that, you could also use the agent lib, or there's also a flag available, include resources, just for information with the native image to add them. And then another topic is class initialization, because at the end you can configure whether you want to initialize classes at runtime or build time, and both could have benefits and downsides. And like, for example, in this example here, if you would compile that with a native image, you're not able to it's not able to find a UTF char set without additional configuration, because that's not part of that standard image component. So it's called a substrate VM. There's only the UTF-16 and I think UTF-16 and one other, 16LE and UTF-8 is part of it. So that's the parts that it also always compiles to it, and therefore it's not able to find that. But if you configure the initializer of that second class as a build time, then it's able to find it, because it knows, okay, I have to include that. But as said, I will just provide that configuration or that source code here, and then you can try it yourself at your laptop. Also regarding, for example, other features are dynamic proxies and serialization that are not working without additional information. And as said, you can always use that agent lib to configure that. And for the initialization, there's also some flags available to do that. Let's now have a look at Spring Native or GraalVM Spring Native, which is at the end a library that supports GraalVM and the features there in the native images. It's a really important topic, not just because all people are looking at serverless. So I know we don't have much time left, but we'll just execute it, and then we can do some Q&A. At the end, it's like that the Spring team supports GraalVM with a Spring Native to get all those performance improvements. It's also, so as of right now, it's available as a beta or pre-release in a library, which you can really easily add. For example, if you have a new application with start.spring.io, you just have to, as a library, type in Spring Native, and then you're able to get the capabilities. The limitations regarding those dynamic features I showed you are the same, but you're able to handle those with annotations. And one other thing I want to talk about or say is at the end, it's like currently it's a library, but it will be deeply integrated into Spring Boot 3 and Spring Framework 6, which will be hopefully available at the end of the year. And so regarding those libraries, you can see here is the Spring Native library, which I included. And then we have some build plugin configuration. You can see that there's also the Paketo build back configuration. And in the profile, which has the name native in my case, you can see that I set the build pack native image to true. So the build pack will build it with a native image build pack because it's not able to recognize that. And you can see there's that build tool native Maven plugin that's there. If you don't want to build a container out of your application as a native image, you could also use those build tools from GraalVM to build it. And in our case, what we will do is, because we don't have the time to build all the steps, we want to build it as an image. And also because of the performance, instead of just doing that via that build image command and specifying our native profile, or if you don't want to have a container, just running Maven profile native package, we will use another component called Tanzu build service, or KPack, that builds the container image for us. And the big benefit is that if it's, let's say, a production, in case of the production, it will automatically update the base image if there is, for example, a new operating system version available. And the CLI for this is kp create image. So we'll execute it, and hopefully then, if I was able to answer 1 or 2 questions, then it will be ready. So we'll now start creating that application, and then at the end we will deploy it. 1 second, just regarding those how to mitigate the dynamic the dynamic features that it's not supported. At the end, it's like what Spring Native provides to you is annotations you can set. So instead of running that analyzer, which is also possible, you normally then just have annotations for those dynamic features. Like, for example, I want to have those 2 classes that are used by reflection with and I'm interested in also having those methods of it as configuration, and then the ahead of time plugin of Spring will generate the configuration for you, and you don't have to do that by yourself. And then for every of the feature, there's more or less one annotation, like, for example, the resource hint here, or also the class initialization is more or less than one annotation available that helps you to mitigate those restrictions. Okay, as long this application is building, we can have a look at whether there's some questions. It doesn't look like yet.
Okay, we've got some questions.
Okay. Yeah. Because I was able to see some, but okay,
yeah. Some of them are from our Discord server. We got a Discord server where we talk about different languages, Spring, of course, and Java. And here the link if you want to join us. And the first one is actually all the common Spring library, JPA, JDBC, security are compatible with GraalVM and Spring Native, or some Spring model is not compatible?
No. So at the end, it's like that. The Spring team is for sure heavily working on making all the typical libraries available. And those one you mentioned, as far as I know, all of them are already compatible. But for sure, it could be if you use some that are not that commonly used, or from the community, that they are not compatible. But then at the end, it's like you can then provide that configuration. So just run that Java agent lib against that library with, for example, the tests you have for a application to create that configuration, and then you can also use that. So for those, in best case, for sure, all those libraries, also Spring libraries, they just do that out of the box, and you don't have to care about. But if that's not the case, you have to provide a configuration. So as you saw, by using that agent lib, for example, to generate it, and you can also do that manually, maybe.
Okay, great. Another question is, there are some tips to optimize the cold start of Lambda.
That's a good question. So I'm not a Lambda expert, but at the end, it's like, well, for sure, what you could do is you package it in a container and optimize, for example, in that container having GraalVM. So I'm not sure. So as far as I know, AWS Lambda is not using GraalVM as a runtime. But what you could do is use a container with GraalVM and all those optimizations, and then deploy that on AWS Lambda. As that, the big benefit of that is having also no vendor login, so you could then also just run it on KNative.
Okay. Another one from Marco Tulici. What is the most problematic activity during a migration of a monolithic application into cloud environment?
I think the most problematic one would be, so at the end, a monolithic application doesn't mean that it's not cloud native. But usually when we talk about monolithic applications, they are not modular at the end. So it's like one big chunk of source code, so no separation. And also in most of the cases, they are stateful. So it's not like that every state is just stored in a database. If that's not the case, so if you have a monolithic application and every state is in the database, and it's also not that big that you would say, okay, it takes a lot of time to start or whatever, then there is not a real challenge. But at the end, what I recommend, if you want to be sure that it's running on a cloud environment, have a look at those typical 12-factor principles, and there you can see it.
Okay, thanks. We haven't got any other questions.
Okay, perfect. So then let's see whether I'm able to show you the deployment at the end, that you see the benefit. I will just here, so it looks like the container image is still building. If not, I will use an image I already created. So 1 second. If I find one. I thought I have one. So at the end, it's like, so what you would see is really a startup time instead of 3.5 seconds, 200 milliseconds, something like that. And also the resource consumption would be, instead of 200 megabyte, around 50 or something like that. And also the CPU. So it's a big benefit regarding the resources. I will just here, so the last minute, I can have a look whether I'm able to find the reason why the application is not building. But we can also, in parallel, for those people that will stay a little bit longer, try to build it here on my local environment. So let's see whether that works. So all those people that want to see it, maybe it will work. If not, yeah. Happy that you were here. I can also share the workshop in a minute with you, that you can maybe have a look at the samples and try it out yourself on your computer if you're interested. And so all those there is a folder with the samples, and then there's also the workshop. And if you go to the workshop, and there's a content with all the samples as MD files, and then you can just follow the instructions. So if can I chat to the folks?
Yeah, you can send me a private message, and I will show. Yeah, this one. This is the link.
Yeah, that's my link. So, and as you can see, so that building, it takes a lot of time, and the problem, so that's, as said, one of the problems. And yeah, the recommendation there is, as long as it's not, maybe in the future they will optimize it that good, that it's possible to also build those native images really fast. But as long as that's not the case, the recommendation is that the developers, they just build the applications to test it locally on OpenJDK. So GraalVM-OpenJDK, for example, or GraalVM-JDK, and on the JVM mode. And then there are CI/CD pipelines that build that native image for you to deploy it. So because as you can see, it takes a lot of time. It consumes a lot of resources at the end, and therefore for developer productivity, it's not the best thing. And therefore, it's good to do that as a CI/CD pipeline, but not on your local computer. I can see what's doing here is really that static code analysis of our application to build that native image, and then it will be where those .native build packs here will be packed into a container. Feel free to ask any further questions.
We have a comment from Marco. Thanks for the good talk. So
yeah,
and I think it's a great talk, and I want to thank you for your time and to share your experience.
Yeah, happy to do that, and also for other topics. So I'm currently, for example, also building a workshop on a cloud native architecture on top of so the solution I'm the specialist for at the end. So using KNative, TensorBuild service, etc. And for sure, also there is GraalVM or native images for serverless component, also one component. And if you're interested, I can also talk about that here. As said, the problem with those GraalVM topics is really that the build takes that long that it's hard to really show all the capabilities if you don't prepare everything, and then I think it's also not that interesting. And it's also good to see that limitation live, because as you can see here, for example, there's a hint to ensure that for that building there is for minimum of 4.5 gigabyte memory available. And I think not every developer has a MacBook for 46 gigabyte or whatever. So it's a big limitation here. But yeah, as I said, so it's at the beginning, so it's really getting a major fast, but at the end it's like there will be some optimizations in the future, and hopefully also regarding the build time. But as you can see, we're here at the last step, and then hopefully the rest, so the container building doesn't take that long, and then we are able to see in hopefully, let's say, 3 to 4 minutes, the result for those that are still there and are interested in it.
Yeah. Now it's creating the image. Yeah.
It was a gradient, so yeah, that's bad at the end.
Maybe some small stuff.
So I'm not able to show you that, so you have to trust me that and as said, you have the source code, just try it out yourself. At the end, you should really see those enhancements regarding the performance, so from seconds to milliseconds with more or less every application that you compile for it. It's really that huge amount of time saved and memory saved, so startup time and memory and CPU saved. So it's a big enhancement at the end.
Great. So thanks, Timo, for a great talk, and thanks everyone to stay with us this evening for this live event. So cheers and stay safe.
Thank you. Enjoy.
Bye-bye.
Bye.
Bye-bye.